Every year, 2.5 million trucks grind over the Alps, choking valleys with noise, pollution, and gridlock. Yet Europe's most ambitious megaproject is tunneling 55 kilometers beneath the mountains to flip the script on transalpine travel. This is not just a tunnel. It is a new backbone for the continent, promising high-speed trains where once only diesel giants crawled. But with mountains of spoil, billionaire budgets, and entire communities holding their breath, can the plan survive the forces threatening to derail it? Here is what is really at stake as the engineering battle for Europe's future begins. Trucks thunder through the Brenner Valley day and night, their engines echoing off the mountainsides. For families living in villages like Gries-en-Brenner, the constant rumble and diesel haze are part of daily life. Each year, 2.5 million trucks cross this narrow corridor, turning what should be pristine alpine AIR into a cocktail of exhaust and fine dust. On winter mornings, a gray smog often hangs between the peaks, trapping particulate matter and forcing children indoors. Noise levels routinely exceed safe limits, with some houses registering over 70 decibels even at night. Local doctors report higher rates of asthma and respiratory illness, especially in young children and the elderly. Traffic jams stretch for kilometers, with lorries idling for hours, burning fuel and patience. Residents describe sleepless nights and gardens coated with black soot. Some have installed triple glazing, but even that cannot keep out the low-frequency roar. The valley's economy feels the strain too. Tourists bypass polluted towns, and small businesses struggle as deliveries get delayed. A local resident sums it up: "We love our mountains, but it feels like we are living in a tunnel of trucks." The sense of frustration is growing. People here know that tinkering around the edges will not solve the problem. With the region's health, economy, and landscape at risk, only a radical change can break the cycle. Beneath the Alpes, engineers are carving out an underground route on a scale Europe has never seen. The Brenner Base Tunnel stretches 55 kilometers from Innsbruck to Fortessa, making it the longest railway tunnel in the world once finished. Its blueprint calls for 2 parallel tubes, each measuring 8.1 meters in diameter, running side by side through solid rock. Every 333 meters, cross passages connect the tubes, forming a safety grid that allows for rapid evacuation and maintenance access. At 3 separate points, underground emergency stations stand ready to receive trains in distress. The tunnel's design solves a central problem: how to move heavy freight and fast passenger trains across the Alps without steep climbs or sharp bends. By maintaining a near-level gradient, trains can race through at up to 250 kilometers per hour, while freight moves steadily at 120 to 160 kilometers per hour. This not only slashes journey times, but also cuts energy use and emissions for every ton of cargo. Excavating such a route demands a strategy as bold as the vision itself. Massive tunnel boring machines, supplied by Herrenknecht, chew through rock day and night. Their work produces a staggering 21.5 million cubic meters of spoil, enough to fill 8,000 Olympic swimming pools. Project director Martin Grodnitzer of BBTSE describes the operation as a logistical ballet, with spoil removed by conveyor systems and repurposed for construction elsewhere. Each advance is measured in meters, but the challenge is measured in decades. The blueprint in the mountain is not just about speed or capacity. It is about building a safer, cleaner corridor for the next century of European transport. At its deepest point, the Brenner Base Tunnel lies 1,720 meters below the surface, nearly twice the height of the Empire State Building, buried under solid mountain. That depth means the engineers are not just fighting distance, but the unpredictable forces of the ALPS themselves. Gneiss, a hard metamorphic rock, dominates long stretches of the route, but the tunnel also cuts through layers of schist, limestone, and dolomite. Each transition can bring a new set of problems. In some sections, the rock is fractured and unstable, forcing crews to reinforce the tunnel walls meter by meter. In others, pockets of pressurized groundwater, sometimes hidden within karst formations, can burst into the excavation with little warning, flooding work sites and threatening equipment. A geotechnical researcher at TU Graz describes the mountain as a living system. Sensors embedded deep in the rock monitor every shift and tremor, feeding real-time data back to control rooms. Even with these precautions, the overburden, the sheer weight of mountain above, exerts enormous pressure on the tunnel lining. In the most challenging zones, the rock can deform over time, squeezing the tunnel and demanding constant vigilance. These variables turn scheduling into guesswork and risk into a daily reality. The deeper the tunnel goes, the greater the uncertainty, and every unexpected geological event can mean months of delay and millions in extra costs. The Brenner Base Tunnel carries a price tag of 8.384 billion euros, split between Austria, Italy, and the European Union. Each partner faces intense scrutiny as costs climb and schedules slip. For Brussels, every euro is conditional. A senior official from the EU Transport Directorate warns that future funding depends on hitting agreed milestones. No breakthrough, no money. Regional leaders in Tyrol and South Tyrol walk a tightrope. The Tyrolean transport minister points to public health gains and cleaner air, but faces voters who are weary of construction noise and truck convoys hauling spoil to disposal sites. In Sturzing, the local mayor fields questions about the mountain of excavated rock piling up near the village, and residents worry about water quality and the scars left on the landscape. Community meetings grow tense when news spreads of worker fatalities. 3 lives lost so far in the dangerous depths of the tunnel have made safety a central concern. Each incident sparks debate over oversight and who bears responsibility. As deadlines approach, the political risk intensifies. If the project stalls, local trust erodes and support from the European Union could vanish. The tunnel's future now hinges as much on social license as on engineering progress. For officials, every delay or cost overrun is more than a budget line. It is a test of credibility with both Brussels and the people who live in the shadow of the construction sites. Freight planners studying the Brenner Base Tunnel face a puzzle that goes far beyond digging through mountains. The tunnel itself is built for speed and volume, but the wires and signals that run through it do not always match up on either side of the border. Austria's North Portal uses 15 kilovolt at 16.7 hertz power, while Italy's South Portal switches to 25 kilovolt at 50 hertz. For a locomotive driver, this means crossing an invisible line where the train's systems must adapt in seconds, or risk a shutdown. Some modern locomotives can handle both voltages, but not every freight operator has invested in these expensive upgrades. The challenge deepens with the European Train Control System, ETCS. Austria and Italy have each rolled out their own versions, and the software baselines do not always speak the same language. During pilot runs, OEBB and RFI engineers found that trains equipped for one country's ETCS sometimes failed to register signals from the other. Until these mismatches are resolved, through running freight remains a logistical headache. Then there is the issue of terminals. Even if a train can make the journey, bottlenecks at Verona or Innsbruck can erase the tunnel's time advantage. Freight operators weigh these risks carefully. As one planner puts it, a flat tunnel is only as fast as the slowest handover. For the tunnel to fulfill its promise, technical harmonization must be more than a political talking point. It must work at full speed every day. Success for the Brenner Base Tunnel will be measured in numbers, not promises. The design allows 260 to 300 trains to pass beneath the Alps every day, more than double the current capacity. For passengers, The journey between Innsbruck and Forteza will shrink by 55 minutes. Freight trains, now slowed by steep climbs and border bottlenecks, will cut travel times by up to 1 hour and 10 minutes. These gains are not just about speed. Environmental groups like Legambiente Alto Adige point to the tunnel's potential to reduce emissions by several million tons of carbon dioxide each year, if enough freight shifts from road to rail. They warn that these targets must become reality, not just projections. Success will be tracked in cleaner air, quieter nights, and the number of trucks taken off the A22. The tunnel's legacy depends on whether these benchmarks are met and maintained, holding every stakeholder to account. Right now, Europe stands at a crossroads. Everyday freight demand rises, and climate deadlines loom. Whether the tunnel delivers on its promise depends on political will and action, starting today. The future of cross-border mobility isn't just being built beneath the ALPS, it's being decided above them.